In this presentation, we're going to explore the Gulf issue of dead zones. So dead zones occur because of a process called eutrophication. So this happens when a body of water gets too many nutrients such as phosphorus and nitrogen. So at a normal level, these nutrients feed the growth of an organism called cyanobacteria or blue-green algae. However, when there are too many nutrients, the cyanobacteria grows out of control, which can be harmful. And human activities are the main cause of these excess nutrients being washed into the ocean. So part of the reason is because of the rapid rise in intensive agricultural practices, industrial activities, and population growth. So if we look at this map of Texas, we can see the different working lands. So everything in blue is cropland. And everything in the pink is orchard, yellow is wildlife management, and green is timber. So human activities have emitted nearly twice as much nitrogen and 3 times as much phosphorus as natural emissions. So this is quite a bit. Now, if we take a look at the nutrient pathway, the Mississippi River and its tributaries drain 41% of the United States and carry the nutrients that causes the Gulf's own dead zone. So it's not just Texas that's contributing these nutrients to the Gulf. All right, so algal blooms. So the eutrophication process has these really severe environmental impacts. So as we talked about, you have the dead zones, and within that, there's something called an algal bloom. So when the phosphorus, the nitrogen, and the other nutrients increase the productivity or fertility of marine organisms, things such as phytoplankton, algae, and seaweeds will grow really quickly and excessively on the water's surface. So this rapid development in algae and phytoplankton is called an algal bloom. And algal blooms can create dead zones beneath them. So they prevent light from penetrating the water's surface. And they also prevent oxygen from being absorbed by organisms beneath them. Which moves us into hypoxic zones. So hypoxic is when the light isn't able to penetrate the water's surface. Oxygen is not being able to be absorbed by the organisms beneath them. So as we know, sunlight is necessary for plants and organisms like phytoplankton and algae, which manufacture their own nutrients from sunlight, water, and carbon dioxide. So by depriving the organisms of sunlight and oxygen, the number and diversity of benthic or bottom-dwelling species are reduced. So the Gulf of Mexico has a seasonal hypoxic zone that forms every year in late summer. So to look at this information in a different format, let's watch this video.
What is eutrophication? It's a problem that should matter to you, whether you live near the ocean or not. That's because it begins wherever people live and ends with damage to resources we all use and enjoy. It all starts when nutrients get into lakes and oceans. Remember, what's waste to humans can be food to plants and other creatures. Nutrients feed algae like they do other plants. Algae grows and blocks sunlight. Plants die without sunlight. Eventually, the algae dies too. Bacteria digest the dead plants, using up remaining oxygen and giving off carbon dioxide. If they can't swim away, fish and other wildlife become unhealthy or die without oxygen. But it doesn't have to be this way. Protecting marine resources starts with sound agricultural and waste management practices.
So specifically the Gulf's dead zone. So the 2020 Gulf of Mexico hypoxic or dead zone measured 2,116 square miles. So this was the 3rd smallest in the 34-year record of surveys. So the 5-year average is now down to 5,408 square miles. But the earlier forecast for the dead zone was higher actually at 6,700 square miles. So the major reason that there was a smaller size was due to extensive mixing caused by Hurricane Hanna, which passed through the Gulf right ahead of the survey crews. Okay, so if storms don't mix the waters, then they remain in layers, right? Isolating the bottom waters from aeration until fall brings cooler surface temperatures, and then the density of the surface water approaches that of the bottom water. So oxygen deficits created by decomposing organic matter in the deeper waters remain. So the extent of hypoxia is determined by the balance between the rate of delivery and decomposition of algae and other organic matter and the rate of oxygen resupply. So to understand seasonal mixing more and why the Gulf's dead zone changes throughout the year, let's watch this video.
Hi, I'm Emerald Robinson, and in this What Is video, we'll examine the question, what is water circulation? In nature, water circulation is the mixing of layers found in a body of water. This mixing helps to equalize the distribution of oxygen concentration, nutrient levels, salt concentration, the amount of waste and pollution, and temperature. While water circulation occurs to some degree in many bodies of water, it's especially important in lakes, estuaries, and oceans. Since lakes are largely still and calm, water circulation is vital to their ecosystem's health. Lake water tends to form 3 layers: top, middle, and bottom. When these layers mix, the lake experiences what is called turnover. Turnover is driven by differences in water density. Cold water is more dense than warm water and sinks. Warm water rises. When air temperatures at a lake's surface get colder, so does the temperature of the top layer. This layer becomes more dense and sinks, forcing other layers to rise and mix. Estuaries form when fresh water from a river's mouth mixes with seawater. Salty water is less dense than fresh water and forms a layer at the surface of an estuary. Since different kinds of organisms can live in different amounts of salt water, water circulation is crucial in an estuary ecosystem. Winds, tides, rainfall, and even storms play vital roles in the rate of an estuary's water circulation. Water circulation in oceans is called thermohaline circulation. Circulation driven by both temperature and salt concentration. Thermohaline circulation occurs when water carried by currents flowing from the equator to the poles becomes cool and sinks, flowing deep below the surface to refill the ocean's basins, then rising back towards the surface as it becomes warmer and saltier. This type of water circulation carries heat to different parts of the globe, affecting land masses and, in turn, climate and weather patterns, even the weather where you are.
So some different solutions. So the key to minimizing the Gulf dead zone is to address it at the source. We can use fewer fertilizers and adjust the timing of fertilizer applications to limit runoff of excess nutrients from farmlands. We can control animal waste so they're not allowed to enter into waterways. We can monitor septic systems and sewage treatment facilities to reduce discharge of nutrients to surface water and groundwater. And we can be careful of industrial practices, such as limiting the discharge of nutrients, organic matter, and chemicals from manufacturing facilities. One thing to look at is different methods of farming styles. So listed on this slide are a couple different techniques. Permaculture, biodynamic farming, kind of along the same vein, also sometimes known as indigenous styles of growing food. These are more organic, growing less in straight crop styles, but more in circle formations, and with more natural inputs to the soil, such as maybe burying a fish or actually algae into the soil to add nutrients rather than a man-made fertilizer. Another technique that's being looked into is agroforestry. So this is a food forest system, and there are cons to these. You know, one of the biggest ones being that they are not incredibly efficient. They require a lot more hand harvesting. Other techniques that are being researched are aqua, hydro, and aeroponics. So these are more indoor systems of growing food. Something else, the way that the Farm Bill is structured, changing that could help with this runoff of nutrients. Yeah, so something to think about. Here's a quote that's about how, like bees, our survival depends on connection to family and community, and just redefining the way that we structure systems. So another solution is by creating riparian buffers on farms, augmentation or aeration. So let's watch this video to get a better explanation.
What is an algal bloom?
Riparian buffers are an area next to streams and rivers or lakes or different water sources that can protect the water from pollutants from the nearby land, whether that be pesticides from a nearby farm or just different waste. If there's like a business nearby or a parking lot or something. These buffers are highly vegetated areas, and they are highly vegetated, so the pollutants or different waste cannot get to the water because they will either be stopped by the vegetation or absorbed by the vegetation. On top of stopping the harmful runoff or waste from entering the different water sources, there are many other advantages that these buffers can bring to an ecosystem without there being many disadvantages to them. So some other advantages that these buffers can bring is that they can provide a food source for different animals in the water. They can provide shelter for different animals in the water. The trees or bushes in the buffer can cast shade on the water, which can control the temperature of the water. These buffers can help stop erosion by making the bank of the water more sturdy. These buffers could temporarily hold off flooding if they had to, and they are relatively cheap and easy to install and create. So basically, they can definitely lead to a healthier ecosystem overall and help the areas around it as well. Some disadvantages of the riparian buffers is that they could take away from farmers' land where they could be potentially planting crops. This problem is actually being countered by farmers getting paid to add these buffers next to water sources on their land, so they're not losing any money from potential crops that they could be planting. And it's kind of a win-win for everybody because the water source is staying healthier with the buffer being installed nearby, and the farmer really isn't losing much to get the money back that they could have been making from those crops planted in that area. And also another disadvantage is that in some cases, it could be hard to add these buffers to an area since some establishments and businesses are built right on different water sources like a lake or a river or something. So some other methods that could be used to stop these algae blooms is biological augmentation, which is basically the addition of bacteria cultures to the, different water sources, which can help get rid of any contaminant that has entered the water. Another example is aeration. So if we're talking about like a pond or something, you could add these aerators or fountains, which would keep the water moving within the pond, which would make it harder for these algae blooms to grow. And another thing is just people caring for their local water source.
So here is the Utah Lake Commission kind of brainstorming another idea to clean algal blooms.
We're out here at Utah Lake. We're out here trying to just harvest some algae out of Utah Lake. The main purpose we really wanted to do is Utah Lake's a great lake and we love it out here. A lot of people like to use it, but it's been infested with blue-green algae, and it has algae blooms which would be kind of hazardous to the animals and the people who want to use the lake. So our goal is to actually try and find a really convenient and practical way to harvest the algae out of the lake.
Our goal is to build a system, a mobile floating, we call it an algae harvesting barge, that will go to the hot spots or the worst spots where the algal blooms are the worst on Utah Lake, and so we can focus on the key areas. We pump the water out and we filter it through our cellulose plate and frame filter press, and that captures the algae but puts cleaner water back in. Full-scale algae harvesting barge will be about 30 feet long, 10 feet wide. We'll be able to pump 1,800 gallons per minute of algae water through the filtration system and remove the algae. That system complete is going to cost.
All right, so now let's shift and look at some art inspiration surrounding algal blooms. So we first have this image created. This octopus is creating the perfect storm for an algal bloom. So you can see that in some of his ingredients, he is adding nitrogen and phosphorus. Next, we have some student inspiration. This piece is by Michelle Hugh, and she shows these creatures that are being clenched by harmful algal blooms. So to see more student work similar to this, visit boc.org.